Hello students, let us try to discuss the mechanics, and in mechanics we will be discussing the projectile. So mechanics, and then we will be discussing the projectile. Projectile is basically your two-dimensional motion, 2D motion. Another example of 2D motion is your circular motion. Now try to understand. If a body is projected from ground or from a height so that it is freely falling, then this is a projectile. For example, here is a ground and here is the body which is given a velocity. It will follow a path like this. You might have observed that a footballer kicks the ball, that takes a parabolic path. This path is parabolic, and this is the trajectory of projectile. Now the initial velocity that has been given to the projectile at an angle theta can be divided into two groups. One is ux, x component, that is u cos theta, and one is y component, u sin theta. It is important to understand that it is not a powered flight. There is no extra power that is being provided to the projectile. If the crow has taken this path, then it cannot be taken as the projectile. It should fall freely into the air, and we ignore the air resistance. We ignore the air resistance. Now here it is important to understand that u is the velocity of projection at an angle theta, whose x component is u cos theta and y component is u sin theta. In this direction, vertical direction, g is acting. So, whereas in horizontal direction, acceleration is 0. So, a projectile can be conceptualized in this way, that two motions are there. In projectile motion, two motions are there. One is the vertical motion, and this vertical motion is accelerated. And second is the horizontal motion, which is uniform in nature. That means velocity constant. Now let us discuss few parameters of projectile. See, there are few terms that we should understand in the projectile motion. This is the path of the projectile that has been given the u velocity at an angle theta. This is maximum height, and from here to here, so one is maximum height, and the time for which the projectile remains in air, that is your time of flight. And one more term is there that we call range, horizontal range. The cause of range is
ux.
At the same time, you will observe that in projectile motion, here you see, this velocity, uy is constant. Everywhere it is uy. ux is constant. Everywhere ux is constant. But you see, this vertical velocity uy, this goes on decreasing, and at maximum height ux remains the same, but this uy becomes 0. So one very prominent question is there that is frequently being asked, that you should understand. At highest point, what is the velocity of projectile? It is not 0. Vertical component is 0, but horizontal component is still your ux, that is u cos theta. At highest point. At highest point, vertical component is still there, that is u cos theta, and it is constant. Here also it is u cos theta, here also u cos theta, here also u cos theta, here also u cos theta. This is the constant. During the motion, upward motion, this vertical component goes on decreasing. Here it becomes 0, and finally during the downward motion it goes on increasing. So this is the projectile, and one more thing is there regarding the parameters. Equation of projectile. Equation of projectile. Equation of projectile is basically the relation between x and y. What is x? X is the horizontal distance and y is the vertical distance. This relation will give you equation of trajectory. And what is trajectory? Trajectory is path of projectile. So mainly we will have to focus on these 4 parameters: maximum height, time of flight, range, and equation of projectile. So let us try to understand with the basic knowledge of kinematics that how that knowledge can be applied here, and we will be able in getting the expression for these terms. Let us try to understand those matters. So for time of flight, we have ux, u cos theta, uy, u sin theta. This is constant throughout the motion, and this is accelerated. During upward motion it decreases, becomes 0, and then again increases. If we want to find the time of flight, the time for which the projectile remains in air, in the ground to ground projection, from ground to ground, here it is a sky, here it is ground. In the time of flight, to derive the expression, we can use the relation S is equals to ut plus half at square, the equation of motion. S is your displacement, u is the initial velocity, half a is the acceleration, t is the time. While using this relation in the vertical direction, in vertical direction, if we see in vertical direction the displacement is 0. So displacement is 0, so we can take 0. Uy, time is your time of flight, plus half ay, time of flight square. uy u sine theta into t plus half ay is your minus g. Why? G is always acting in this direction and this direction we take as negative, and then t square. So what we are getting? T will cancel and we are getting time of flight is 2u sine theta by g, and this expression should be remembered by the student. While solving the numerical, it will be very helpful. This time of flight has two portions. One is time of ascent plus one is time of descent. So time of ascent is equals to time of descent is equals to u sine theta by g, upward from here and here to here. So we are getting the first expression for time of flight, t is equals to 2u sine theta by g. First expression we have got. Now let us move to the next expression, that is expression for maximum height. For maximum height of the projectile h, if we take the vertical motion, because h is due to the vertical motion this. So here what we get? The vertical component Vy is 0 and Vx is equals to Ux, that is u cos theta. So if we want to find the maximum height, then try to understand the expression for it. We are using V square is equals to U square plus 2AS. This relation we are using in vertical direction. Now in vertical direction, if you will observe, at maximum height this is 0. This is initial velocity u sine theta whole square plus 2, a is your minus g and s is your h. So what we are getting? We are getting h is equals to u square sine square theta by 2g. Second relation we are getting, that is for maximum height, h is equals to u square sine square theta by 2g. Now third relation that we have to find for the horizontal range. If we want to find the horizontal range cos is your this uniform velocity. So horizontal range, that means from distance O to A, this R is equals to horizontal velocity u cos theta into time of flight, that is u cos theta into 2u sine theta by g. What is 2u sine theta? Sine 2 theta. So this is the formula that you should remember, that horizontal range R horizontal range R is equals to u square sine 2 theta by g. If we talk about maximum, R maximum, horizontal range will be maximum when sine 2 theta is maximum. And what is the maximum value of sine 2 theta? Sine 2 theta maximum is equals to plus 1. That is sine 90 degree. So 2 theta is equals to 90 degree. Theta is equals to 45 degree. What we can say? We can say that horizontal range is maximum when angle of projection theta is 45 degree. At 45 degree, the horizontal range is maximum. So this data also you should remember, this fact also you should remember, that horizontal range is maximum when theta is equals to 45 degree. At 45 degree, the horizontal range, this distance is maximum. Now you see, if we replace theta by 90 minus theta in the formula for horizontal range, then R dash is equals to u square sine 2, at the place of theta I am writing 90 minus theta by g. This is giving you u square sine 180 minus 2 theta by g, and sine 180 minus theta is 2 theta, so you are getting u square sine 2 theta by g. R dash new range, and that is equals to R. So what we can conclude? We can conclude that there are two angles of projection for which we have the same horizontal range. If one is theta, other is 90 minus theta. So theta and 90 minus theta, these are two angles for which we are getting the same horizontal range. If one is 30, other is 60, same range, provided initial velocity remains the same. If one is 40, other is 50. If one is 20, other is 70. For all the angles, complementary angles, the range remains the same. That means horizontal range remains the same for two angles. One angle is your theta and other angle is 90 minus theta. For this you will be getting the same range. Now try to understand. In the discussion, I have said one angle is theta, one angle is 90 minus theta. This is theta and this is 90 minus theta. If this height is h, from here to here and from here to here, better you take h1, this height you take h2. A, B, C. AB is your h1, AC is your h2, and range is your R. This high range is your R. R tells about it. Now you have to find the relation. Find relation between h1, h2 and R. See, h1, velocity of projection is your u at an angle theta. h1 is equals to u square sine square theta by 2g. H2 u square sine square 90 minus theta by 2g. If I multiply H1 and H2, then see what we are getting. H1 into H2, this is giving u to the power 4. This is your cos square theta. Sine square theta into cos square theta by 4g square. This can be written as u square sine square sine theta cos theta 2 divided by 2 whole square by 2g whole square. We can write in this way: u square whole square u to the power 4 sine theta cos theta 2. Now this value, this is not required, g square into 8. So what we are getting? We are getting u square sine 2 theta by g whole square into 1 by 8, and this is your what? R square by 8. So we can get it that H1 and H2, H1 into H2 is equals to R square by 8. Here we have done mistake. Here it should not be 8. Here 2 square is coming. So we should write here 2 1 more. So here 2 1 more. Here 2 1 more. Here 2 1 more. So R square by 16 should be there. Because here actually it is coming 2 square. So here we should write 1 2 I have already written. Another 2 I should write, and so it should be R square by 18. So this is also one of the relation that you should understand in a very careful way. U4 sine square theta cos square theta H1 H2 u square into 2 sine theta cos theta, this will become 4. So I have had to multiply by 4. 1 4 is already there. So 4 into 4 16. 16 should be there, and ultimately this value is giving you the value of R. So R square by 16, and ultimately we are getting the relation that exists is your H1 into H2 is equals to R square by 16 for same range, the two height that we are getting. So this also relation is very helpful for solving the problems. Now let us try to discuss one more relation, that is R we have seen u square sine 2 theta by g, and H we have seen u square sine square theta by 2g. So if we divide R by H, what we are getting? U square sine 2 theta by u square sine square theta. Here g, here 2g. G will cancel, u square will cancel. 2 sine theta cos theta by sine square theta, square will cancel. 2 2 ja 4, 4 tan theta. Therefore R is equals to 4h tan theta. No. We have got. So here what we are getting, it is not 4 tan theta, it is your 4 by tan theta. So what we are getting, R tan theta is equals to 4h. This relation is also helpful in solving many numericals in a proper way. That we will solve few numericals also on this concept. Certain numericals will be based on the objective pattern, and certain numericals will be based on the problems, will be based on the direct based of the application of the formula that we have learnt. And then we will try to see some advanced level problems also, how the concept can be utilized in getting the proper answer in the projectile motion. Now the last portion that is left in the projectile motion is the equation of trajectory. Let us try to understand the equation of trajectory. If we want to understand the equation of trajectory, as I told you, it is the relation between x and y. Here P point is there, coordinate is x and y. So this distance is y and this distance is your x. We have to find the relation. If we take it, the horizontal distance, the velocity of projection is your u, this is your ux, this is your uy, this angle is theta. So x is equals to u cos theta into time. After time t, the projectile position is pxy. X is horizontal motion, horizontal is constant, so u cos theta. This is basically ux into time t. Ux into time t. Why? It is constant, it is uniform motion. So what we are getting? We are getting t is equals to u, t is equals to x by u cos theta. Take it as equation number 1. If we talk about the y, the vertical distance y, vertical distance, this uy is going to play the role. So y is equals to uy t minus half g t square. And if you see it, uy is your u sin theta into t is your x by u cos theta minus 1 by 2 g, t is your x by u cos theta. See here, whole square, gt square. So what we are getting? U will cancel. We are getting y is equals to x tan theta minus half g by u square cos square theta into x square. This can be written in this form: ax minus bx square, which is the equation of a parabola. So as it is the equation of a parabola, so the projectile path, this path trajectory is parabolic in nature. So this equation confirms that the path of the projectile is parabolic in nature. This much amount of theory is sufficient enough to make you the basic understanding of projectile And keeping this much theory in mind, in the next class we will be discussing the problems based on this concept, the concepts that we have learned, and then we will try to further clarify the concept by solving the problems on this concept. Thank you. Have a nice day.